Usually, like you look in the mirror, you see a complete person.
Right. A unified self.
Yeah, exactly. You look into your own eyes, and there is this undeniable feeling of, well, me. Your joys, your sorrows, that embarrassing thing you said 5 years ago.
We all have those, yeah.
Right. Your ambitions, your feeling of free will, it all feels like it belongs to this singular glowing spark inside you.
It is arguably the most intuitive feeling we have as human beings.
Mm.
We experience ourselves as this cohesive spirit, like a mind that is temporarily driving around a biological vehicle.
But what if I told you that everything you consider you is literally nothing but a wet pack of firing neurons?
Like no glowing spark at all.
None. No pilot in the seat. Just biology. And that is the rather violent disruption to our worldview we are exploring today on this deep dive.
It really is a massive shift.
It is. We are basing this on excerpts from Nobel laureate Francis Crick's book, The Astonishing Hypothesis, The Scientific Search for the Soul. Okay, let's unpack this. The core claim of the book is that Lewis Carroll's Alice could have summarized this entire scientific worldview by simply pointing at you and saying, "You are nothing but a pack of neurons."
I love that framing.
Yeah.
It is a brilliant way for Crick to frame it because it doesn't shy away from the inherent shock value of the idea.
It's super jarring.
Yeah, and to really understand why that feels so offensive to us, I mean, if we connect this to the bigger picture, we have to look at the historical pre-scientific view of the soul.
Right.
For millennia, the soul was defined as a living being without a body, an immortal essence that possessed reason and free will. And honestly, before the spectacular advances of modern science, that myth wasn't just comforting, it was incredibly plausible.
Because, if you think the Earth is the center of a very small, very young universe, and you don't know what gravity is, so you assume, angels are pushing the planets around.
Exactly.
A non-physical soul just fits perfectly into that logic.
Precisely. The supernatural was literally the only vocabulary available to explain complex phenomena. But then the scientific revolution happened.
Things change.
Right? We learned the Earth is actually 4.6 billion years old. We mapped the stars. We discovered atoms. And most critically for this discussion, we decoded molecular genetics and evolution. Take embryology as an example.
Let's say embryology.
Yeah, so 100 years ago, scientists performed an experiment where they took a fertilized sea urchin egg, and after it divided into two cells, they physically separated those cells.
Wait, they just cut them apart?
Yeah, pulled them apart.
And the logical assumption would be that you just killed it, right? Or at best, you'd grow two half urchins.
Right, but instead, the molecules reorganized themselves and produced two complete, albeit smaller, sea urchins.
Oh, wow. Which, to a researcher in the early 1900s, that must have looked like literal magic, like some invisible life force had been cleaved in two and miraculously healed itself.
It absolutely seemed to demand a supernatural explanation. But today, we know it's not magic. It is just the immensely powerful, versatile mechanics of protein synthesis, and molecular instruction encoded in DNA.
So it's just a machine doing its job.
Exactly. The history of science is essentially a graveyard of claims that something was inherently impossible to understand without appealing to the supernatural. Crick's argument is simply that the human brain is next on that list. We simply have no need for the hypothesis of a non-biological soul anymore.
Okay, so if we're going to accept that we are just biological machines, we have to look at the manufacturer. Because, my brain instinctively wants to believe that if I am a machine, I was built by a master engineer.
A very common feeling.
Right, a pristine, forward-thinking designer who laid out all my neural pathways on a drafting board, but the reading makes it very clear that this is a total fantasy.
A complete fantasy. The molecular biologist Francois Jacob famously said, evolution is a tinkerer.
Tinkerer.
Right. Evolution does not have a blueprint. It builds opportunistically.
Yeah.
It just takes small, random genetic steps, and it modifies whatever hardware is already sitting there.
The analogy I kept thinking of while reading this was a house that has been endlessly renovated by 10 different generations of overly ambitious amateurs.
Oh, this did.
You have got this brand new smart home wiring, but it's haphazardly layered directly over the original 19th century lid plumbing. You've got a room that used to be a pantry, and now it's a bathroom, but the light switch is still out in the hallway.
Yeah, exactly.
It is highly functional, you can live in it, but if a modern architect tries to sit down and decode the blueprint logically, it is a complete mess.
That is a phenomenal way to visualize it.
Yeah.
And it really explains why decoding the brain is so incredibly difficult for neuroscientists.
Yeah.
It is just a messy accumulation of interacting gadgets that were layered on top of each other over millions of years of survival pressures. Now, when you suggest that our pristine, elegant minds are just the output of this messy biological tinkering, people naturally resist. A common philosophical argument you hear is that comparing the mind to a biological machine is a category mistake.
A category mistake, like if I tried to measure the color blue in pounds or ounces, I'm applying a physical metric to something that doesn't exist in that realm.
That is the argument, yeah. They claim that the mind and the brain are fundamentally different categories of existence, so you just can't reduce one to the other. But history proves that our human-invented categories can simply be wrong as science advances.
Like what?
Well, the text uses the example of ancient medicine. For centuries, brilliant physicians categorized human health by the four humors. Blood, phlegm, choler, and black bile.
So if you were sick, the doctor essentially said your black bile was like out of category alignment.
Yes, exactly. And today, if a doctor tells you that you have a viral infection, you don't say, well, you are applying the wrong category to my black bile.
Right, because that's ridiculous.
We recognize that the category of humors was a complete fiction. Crick argues that the categories we currently use for the mind, these mystical separations between spirit and flesh, might turn out to be just as fictional when neuroscience finally maps the hardware.
I hear that, but let's be honest. Even if the science is incredibly strong, my brain actively fights this concept.
Right.
And the source text outlines three main hurdles, three massive reasons why this astonishing hypothesis is so viscerally hard to swallow. The first one is reductionism and this concept of emergence.
Reductionism is basically the idea that a complex system can be completely explained by the behavior of its parts and their interactions. It is the engine that drives modern physics and chemistry.
But here is where I struggle, and where I think a lot of people listening probably struggle too. Doesn't reducing the mind to just atoms and molecules completely destroy the magic of the whole?
How so?
Well, you can't just look at a carbon atom under a microscope and find a memory of your childhood, or a joke, or a feeling of dread. It feels like a fundamental truth that the whole is greater than the sum of its parts.
You are touching on the exact friction point of this first hurdle. We desperately want the whole to be magical, but this is where the scientific meaning of emergent behavior is so crucial.
Okay.
It doesn't mean something mystical is happening. Let's look at the source's example, the benzene molecule. Benzene is made of 6 carbon atoms and 6 hydrogen atoms arranged in a ring.
So basic chemistry.
Right, basic chemistry. But the chemical properties of benzene, how it reacts to other chemicals, how it absorbs light, you cannot find those properties in a single carbon atom or a single hydrogen atom.
Interesting.
And you can't just do simple arithmetic and add their individual properties together to get benzene. Those brand new properties emerge from the specific, highly complex way those 12 atoms physically interact with each other in that ring structure.
So it's about the interaction, not just the parts.
Yes. It's not magic, it's just quantum mechanics. Nobody looks at benzene and derives deep spiritual satisfaction from saying it is greater than the sum of its parts.
But we absolutely do that with the brain. Because I can't intuitively understand how billions of interacting cells create a thought. I just assume the thought must exist in some separate magical realm.
Exactly. Because the brain is overwhelmingly more complex than a benzene ring. We assume its emergent properties, like thoughts and awareness, must be mystical. But scientifically, it's just a vastly more complicated version of the same phenomenon. The behavior emerges from the mechanical interaction of the parts.
Okay, so even if I accept that my brain is a complex biological machine, like a giant benzene ring, that still doesn't explain the internal movie playing in my head. A benzene ring doesn't feel pain, right? It doesn't see the color red.
No, it doesn't.
How do we leap from cold chemistry to subjective feeling? Which leads us directly into the second hurdle, qualia.
Qualia. This is the thorniest issue of all in the philosophy of mind.
So what does this all mean? Qualia is essentially the vividness of a sensation, the redness of red, the painfulness of pain. Like if I stub my toe, it hurts, it throbs. I can look at an fMRI and see the neurons firing in my brain, but those firing neurons don't physically feel like pain. The pain feels like pain. So how can a physical wet cell explain the subjective invisible feeling?
It is incredibly difficult because you can never perfectly communicate the redness of red to me. I can never step inside your consciousness and know exactly what a sunset looks like through your specific mind. But Crick proposes a really pragmatic scientific workaround to this philosophical trap.
What's the workaround?
The search for the neural correlate.
The neural correlate, meaning like a specific physical pattern of activity that perfectly reliably matches the mental event.
Exactly. Crick argues that we don't need to solve the philosophical mystery of subjective experience on day one. Instead, if we can prove that the exact neural behavior for seeing red is identical in your brain and in my brain.
Like the exact same cells firing.
Right. If the same cells fire in the same sequence every single time we experience red, we can scientifically infer that we experience it in a highly similar way. If we map the biological correlate, we don't need to philosophically prove the feeling. We just need to understand the mechanism that reliably produces it.
It's like saying, I don't know exactly how the invisible TV broadcast wave turns into an emotion when I watch a sad movie, but if we both have the exact same antenna receiving the exact same signal, we can just assume we're watching the same show.
That is a very helpful way to think about it. Which brings us to the third hurdle, which we will only touch on briefly because Crick himself basically tables it. Free will.
Oh boy. Free will. The absolute, undeniable feeling that you are sitting there right now making the conscious choice to listen to this.
It feels very real.
I mean, I feel like I am choosing what words to say right now.
And you do. But Crick is incredibly pragmatic here. He believes we must solve the problem of basic awareness first. Free will is simply too complex to start with. And frankly, as he suggests, the feeling of volition might just be a highly sophisticated illusion generated by the brain to help us navigate the world.
An illusion. Wow.
Yeah, we have to understand how we are biologically aware of a choice before we can even begin to understand if the choice is actually free or just a mechanical inevitability.
It's just staggering to think about. And honestly, it makes total sense why philosophers have argued about these three hurdles for centuries without getting anywhere. What is interesting in the reading is that because the philosophers were stuck, scientists eventually decided to step in and try to define consciousness themselves.
They did.
But the history of psychology's century-long struggle with this is wild. It reads like a story of a field wrestling with a ghost and then eventually just deciding to pretend the ghost doesn't exist out of sheer frustration.
It is a fascinating historical arc. In the early days of experimental psychology, we are talking the late 19th century, consciousness was the main event. It was literally the only thing they cared about.
It's funny, looking through the sources, you see these early psychologists grappling with it in ways that seem surprisingly modern today. Like William James in 1890. He argued that thought inevitably involves attention.
Yes.
He defined it as the mind taking possession of one out of several possible trains of thought. You have to withdraw from some things to deal effectively with others.
Very prescient.
And even earlier, a guy named Charles Richet brought up memory. He argued that if a pain lasts 1/100th of a second and leaves absolutely no recall, it wasn't truly felt at all.
This raises an important question, though. If these early thinkers correctly identified attention and short-term memory as the foundational pillars of consciousness, why didn't we solve this 100 years ago?
Right, why did we stall out?
The answer is that psychology entered what we might call its dark ages regarding consciousness. This was the behaviorist movement.
This is the era of John Watson and B.F. Skinner, right? The era of putting rats in mazes and ringing bells for dogs.
Exactly. The behaviorists wanted to make psychology a hard, undeniable science like physics. And since you cannot physically measure someone's internal thoughts or feelings, they made it completely taboo to even talk about the mind.
Just off limits.
Totally. The brain was treated entirely as a black box. You introduce a stimulus, you measure the physical response, and you completely ignore the dark, invisible space between the two.
Which sounds completely maddening. You are studying the mind by aggressively ignoring the mind.
It was extremely limiting. But eventually, in the late 1950s and 60s, we get the cognitive revival. And what sparked this was the invention of computers. Suddenly, psychologists had a brand new vocabulary. They started comparing the brain to a computer processor.
And the text outlines several prominent cognitive scientists who built these incredibly complex models of consciousness based on that computer metaphor. You know, you have Philip Johnson Laird proposing that the brain needs a high-level operating system to prevent all its parallel processes from collapsing into chaos.
Right.
Then Ray Jackendoff argues for an intermediate level theory, suggesting awareness lives in the fast processes of short-term memory, not in raw sensation or high-level thinking. And Bernard J. Bars comes up with this global workspace idea where unconscious specialist processors compete to project their information onto a central stage.
What's fascinating here is the absolute consensus among these modern cognitive thinkers. They all agree that consciousness is an active process.
Okay.
They all agree it heavily involves short-term memory and attention.
Hmm.
And critically, they all agree that consciousness does not represent all brain activity. In fact, most of what your brain does, regulating your breathing, decoding language, balancing your body, is completely hidden from your conscious awareness.
But, and this is a huge critical, but in the source text, Crick looks at all these cognitive scientists, and he is incredibly frustrated with them.
Why is he frustrated? Because they are still treating the brain like a black box.
Still.
Yes, they are drawing intricate software flowcharts, saying, here's the operating system, here's the global workspace. But they completely ignore the actual hardware. They treat the mind like a computer program running in the cloud, completely detached from the wet, messy, biological neurons that are actually doing the work.
It is like trying to understand how a car engine works by only studying the traffic laws. You have to open the hood.
Exactly.
And that is exactly what Crick and his colleague Christoph Kost decided to do. They bypassed the philosophical debates, they bypassed the high-level psychological software models, and they launched a targeted biological tactical strike.
You can't win a war by attacking everywhere at once. You have to find the weakest point in the enemy's line.
And their battle plan is brilliant because of what they choose to ignore. They say, look, no premature definitions of consciousness. We aren't going to argue about what consciousness is for, and we are dropping the assumption that language is required for consciousness.
Which is huge, because that frees us up to study animals, not just humans.
Right. So if you drop all of that, you are left with a very specific, testable target. Here's where it gets really interesting. The chosen target for the ultimate biological hunt for consciousness is visual awareness, just the simple act of seeing.
It seems almost too mundane, doesn't it? When we think of consciousness, we think of poetry and deep existential angst. But targeting visual awareness is a total masterstroke of scientific strategy.
Why is that?
Well, humans are profoundly visual creatures. A huge portion of our brain is dedicated to it. Experimentally, the inputs are incredibly easy to control. You just change the picture you put in front of the subject's eyes.
That makes sense.
And crucially, we can ethically study the visual cortex of animals like macaques and cats, whose visual hardware is remarkably similar to ours.
The text mentions the Nobel-winning work of David Hubel and Torsten Wiesel here. They studied the visual cortex of anesthetized cats, and they proved that you could actually map how single, specific neurons respond to a line of light at a specific angle.
Groundbreaking stuff.
But, as the text points out, doing that on an awake, conscious animal who is actively looking around is astronomically harder. Still, it's the only way to find the actual neural correlate of visual awareness.
And when you start looking closely at the hardware of how the brain processes vision, you run straight into a massive logistical nightmare that neuroscientists call the binding problem. This is the ultimate puzzle of awareness.
Okay, break this down for me, because this absolutely blew my mind when I read it.
Sure. So when you look at a visual scene, your brain does not take it in as a single unified photograph. It completely deconstructs it.
Deconstructs it how?
Different physical geographic areas of the tissue in your brain process the shape of an object, the color of the object, and the movement of the object. They are physically separated in the meat of your brain.
So if I am looking at, like, a red square moving to the left and a blue circle moving to the right, the redness and blueness are processed in one area.
Yes.
And the squareness and circleness are processed in a completely different area.
Right, again.
And the motion is processed somewhere else entirely.
Exactly. So the binding problem asks, how does the brain unify all those geographically separate neural firings into a single, seamless conscious object? How do you perceive a moving red square without the brain accidentally combining the redness with the circle, or the leftward motion with the blue? There is no single screen in the brain where all the image data is sent to be projected.
It is physically separated. So how does it bind it all together into the seamless movie playing in our heads? And this is where the biological hypothesis finally drops. The leading guess for the actual mechanism of consciousness.
The hypothesis is correlated synchronous firing of neurons.
Synchronous firing. Explain how that solves the problem.
Think of the brain like a massive chaotic orchestra playing in the dark. The violins are in one room playing the color notes. The brass section is in another room playing the shape notes. The percussion is somewhere else playing motion. If they're all just playing independently, it sounds like chaotic noise.
Bottle racket.
But the idea of synchronous firing is that all the disparate neurons responding to the attributes of that specific red square The red neurons, the square neurons, the left motion neurons, they all begin to fire at the exact same millisecond. They synchronize their electrical pulses.
They sync up to the exact same conductor's baton.
Yes. This synchrony, which is driven by attention and short-term memory, is the biological signature that binds them together. The synchronization itself is the screen. The melody emerges from the timing.
Wow.
And any neurons processing the blue circle are firing to a completely different beat, separated by mere milliseconds, so the two objects never get mixed up in your awareness.
That is incredible. It transforms consciousness from this mystical, glowing aura of a soul into a highly precise, timing-dependent electrical mechanism. It's just a rhythm.
It is a profound shift in how we understand ourselves. It demands that we look at the wet, messy, evolutionary tinkering inside our skulls and recognize that this is where the magic actually happens.
Okay, let's pull back and look at the massive journey we've just taken. We started with the astonishing, almost offensive hypothesis that everything you are is just a pack of neurons.
We did.
We defended the idea of biological reductionism, the benzene ring, against the pre-scientific idea of a magical soul.
Ugh.
We watched psychology struggle for a century, from the dark ages of the behaviorist black box to the cognitive software models.
Quite a history.
And finally, we arrived at Crick's razor-sharp biological battle plan, hunting for the neural correlates of visual awareness through the synchronous firing of brain cells, the orchestra in the dark.
It is a radical framework, but it provides the first real, tangible roadmap for solving the oldest mystery of human existence.
And I want to leave you with a final provocative thought based on this text. The book emphasizes that the brain heavily deceives us about the reality of the outside world to give us this seamless, unified experience.
It does.
But if our vivid conscious experience, like our very existence as a self-aware entity, is nothing but the synchronized firing of neurons held in short-term memory, what exactly happens to you during the microseconds when those neurons inevitably fall out of sync?
That is a chilling thought.
Are we constantly blinking in and out of existence, fraction of a second by fraction of a second? Are we completely blind to the microscopic gaps in our own consciousness?
Yeah.
We might just be a pack of neurons desperately keeping the rhythm going so the illusion of me doesn't collapse into the dark. Think about that the next time you look in the mirror. Thanks for joining us on this deep dive.